For this problem, we're asked what is the low frequency voltage gain for the amplifier shown, and we're given something that looks like this. We're going to neglect the effect of channel length modulation and body effect. Now this looks very similar to a previous problem that we did, and it's in the playlist linked below the like button, but here we have a diode, whereas here we have a MOSFET. Now with this, we're going to look at the notes, and the notes are saying that on page 143 we have a common source amplifier, a common gate amplifier, and a common drain amplifier. Now between all three of these, it looks like either a common source amplifier or a common drain amplifier. At first glance, because there are nuts on the bottom, it will be a common drain amplifier. But notice the direction of our M1 arrow. For both of these, we can see it's pointing to the right, and for our equation here, it's pointing to the left. So it's going to be the opposite. That means it's going to be the common source amplifier here. So we are going to use CS to solve this problem. Now, we can scroll down a little bit until we get a little bit more information about that. So with our CS, it's going to look something like, not that, but this. So we have a lot of notes here, and the important one that we need is the gain, right? Because the problem's asking us for frequency voltage gain. And the frequency voltage gain is just going to be this AV value. So we can take this and plug it right here. Now, there's a few things that are missing here. First is our GM. We don't know our GM. Now, previously, if we look at here, we were given our I value and we were given some V value. Now, for this one, we are given a I value, but we don't exactly know our V value. And so what we're going to have to do is going to turn to page 192, just 92. And this is where we find our gain, because it's asking us for our GM here. And that's going to be the same as this value right here as well. So we need to find our gain. Now, the gain for this, what it's going to look like is we are going to have this middle equation, because that's what everything encompasses for everything that we have. GM is equal to, we have the square root of 2 times our K apostrophe times W over L over our ID. And we have all of these values. So we're going to take this and we're going to plug it in, and that's going to give us about 1.424, and this is going to be in milliamps per volt. So milliamps per volt is equal to our GM. So we would need to plug that into the top and the bottom part. Now our R naught is given to us. It's given to us for, in this problem, as a RD. We don't want to find our R naught. We want to find what's associated with the value that we have here. So ID, we have RD. So this value is not going to be R naught, it's going to be RD, and it's going to be 48.7 times 10 cubed. Now we have our GM, which we're plugging in, and then our GMB and GDS. Well, how do we find these? For our GMB, what we have is a 0 with our body effect. So, or without body effect. And we can solve this, not in these notes, but if we go back here, it says also the amplifier transient is the same GM as in the shortcut. And for our shortcut, which if we scroll up here, we are going to see that our ID is equal to IS, which is GM 0 and VG, and this is all going to be zeroed out. So it talks a little bit about it here. We don't really go into it here, but we talk about the equations GM, GMB, and GDS, sometimes referred to as the G all. So all the G's here, and it's for our FET, and these G's are going to be equal to, and this is important only if we neglect the effective channel length modulation. So if we have this here, and what we're doing is we're saying that the without body effect, so we'll do no body effect, then our GMB is equal to 0. And then we also have this GDS, and then this GDS without channel length modulation is equal to 0 as well. So we would plug zeros in for both of these, and now we're just left with our RS, and we are given our RS as 0.9 kilo ohms. So we plug this in as 0.9, and the K is just 10 cubed. Now, for this problem, all we got to do now is plug this into a calculator. And if we plug this into a calculator, we're going to get approximately negative 30.39, and this is going to be for our frequency voltage gain, so our AV. And that is going to be the answer to this problem and how we would look about solving it, how we would be using the notes as well. And if we wanted to go a little bit more in depth, solving for resistances and a little bit of an aside example here, we would look at these provided by the professor.